This is Mrs. O'Neill for Chapter 5, Review Questions and Problems. And when I think about thermochemistry, I think about fire. But we want to remember that that heat is really heat energy, right? In the form of energy, those molecules moving. So you're going to go through the video by pausing when you see that question or problem, and some of them have multiple parts. You can answer mentally or on paper. Again, I strongly suggest having your calculator and your reference sheets. You're going to then continue playing the video to see those answers, and some of these are going to be above and beyond what you're going to see on the test in class, but will help you on the AP exam. So here's your number one, and again, I've highlighted a few things as well. So hopefully you paused, you read through all that, and you came up with your answer. We also want to remember here that specifically 1 mole of methane, and this is why you see that fraction 3/2 of oxygen, because we want everything to be 1 mole of your methane gas that is being combusted or burned. So here's your answer to B. Again, you probably needed to use a reference sheet or your a book in order to find these delta H values, your enthalpy values, and then I did products minus reactants. I did not show you all of that mathematical work. Most of you should be able to put that into your calculator all at one shot. Notice, however, they are all negative, and if they are all negative, that means they are all exothermic. So again, this is one of those justifications or explanations of that answer. And if you notice the slide, or I should say the graph, this next slide shows you the graph of the 3 different products. And this corresponds to those 3 different delta H or enthalpy values. So your product of just carbon, your product of carbon monoxide, and your product of carbon dioxide. So notice, depending on the products, it gives us a different delta H value, more negative, right, as we go down. Number 2 is considered an activity series. So again, this is one of those above and beyonds. If you're looking at these reactions, can you answer these questions by inferring or going back to those reactions? All right, so hopefully you have an idea of what's going on here. So number 1, you should have been able to balance, but you're balancing it by the charge. So again, number 2 there is a little tricky, something a little different, right? We will go from Fe to Fe plus 2. So we want to make sure that we have 2 positives, and the only way we're going to get the 2 positives is from the Na to equal the 2 positives to the iron. Hopefully that makes sense. And B, again, your products minus reactants to give you your delta H value. Again, your delta H here are exothermic, but your middle guy here is endothermic. Okay, so hopefully that makes sense. And here's your C answer. Again, you want to always think about that thermodynamically favored. Your exothermics reactions are more thermodynamically favored. And D, again, pause and make sure you're understanding what this information is really referring to, those 3 reactions. So if you have to rewind the video to look at those reactions, or notice on your paper those 3 reactions and what's really occurring. All right, number 3, calorimetry. Again, pause and do the work. Here's your answer to A. Answer to B, answer to C, and I'm sorry I made that as big as I could to put it on the slide so you can see it. D, and we want to take a look over here, right? Your Q is not kilojoules, or I should say your Q is usually the unit of kilojoules, but your delta H is your units of kilojoules per mole. So that's why here your delta H value, you're taking into consideration how much moles are there. So we always want to think about our units and make sure that our answer corresponds to the correct units that it pertains to. So again, Q is just heat in kilojoules, but enthalpy, delta H, is our kilojoules per mole. So hopefully that makes sense now. All right, good luck on the test. See you in class.